Well, John, it's an honor and a pleasure to interview you. So how long have you been active in the automation industry?
Jesus, let's see. It's been 55 years.
Wow, amazing.
Yeah.
So I think you're one of the pioneers of the OSIsoft/AVEVA PI database replication solutions.
Yeah. I first started on Pi with Windows for Workgroups. How long ago was that?
Wow. So what would be your advice for OT IT projects when they want to connect Pi data archive servers across the air gap with a data diode? Which is the best possible setup there?
It'd be the one I wrote.
Yes. And why is it better?
Because it's using the Windows API and it's supportable, right? So any changes in the Pi database can be reflected into the API, into the SDK, and we can issue a new copy of the software with an updated SDK to handle the changes in the Pi database, and it's the fastest.
Okay. What is the largest size of Pi data archive servers we can handle?
It's not just the size of the Pi database, it's how much it changes, and I think that we've tested right now up to, I think we've gone to 500,000 points with it. And it will handle 50, 60, 70, 80, 90,000 changes a second, you know? If you want to go bigger than that, then you just have to go with a bigger flanker, really a bigger server, but the software will handle it.
Nice. So I've noticed that OPSWAT has two kinds of Pi replication, two solutions for AVEVA Pi. One is Pi replication and the other one is Pi to Pi.
Yeah.
Do you have a short explanation what the difference is between the two?
Good example is one of our customers that will remain nameless in the Middle East. They opted for Pi to Pi just because they have multiple sites feeding into one Pi database, and they did not want to allow the possibility of any corruption at all into their main Pi database that all these other databases were funneling into. So they're using Pi to Pi, which guarantees that none of the database structure in the receiving Pi database can get changed. Pi to Pi, or Pi database replication, is if you want a true replication of your Pi database, reflecting everything in that Pi database changes to attributes, add and delete records or whatever. So the ultimate in security is Pi to Pi because you're guaranteed not to have any changes to the Pi database, but still have all your data.
Wow, that's great. Let me ask you something from first-hand experience. So once I was migrating between two Pi data archive servers, okay, and then we had a situation where the current states in the destination database did not reflect until the measurements in the OT environments actually changed. So it took us maybe a few hours to get the real state in the destination. I think you overcome this problem in OPSWAT?
I fixed that.
And how did you do it?
The source flankers on the blue side, the people that are the thing that's actually collecting data from Pi, it retransmits all of the Pi data at a rate of 1,000 points a second from blue over to red, so that if anything changes while the other Pi system is down, this will catch it. And on the red side, what it does, it looks at the value coming from blue, and it doesn't know if it came from, am I looking at retransmitted data or am I looking at an honest change in value, because either one will show up over on red. So what it does is it looks at the timestamp of the data coming from blue, and it compares it with the timestamp of the data as it exists on the destination Pi server, and will only update the value if the value coming from blue is newer.
So let's switch gears a little bit. So obviously companies, they implement a lot of Pi data archive server, air gap across the data diode to PI data archive server solutions. But in larger multi-site projects, it's more economical to implement OPC servers in the OT side. Do you also have some solutions for that, where we basically read from an OPC server in OT, cross the air gap, and then ultimately get the data into the PI data archive system via the interface?
You mean like, well, we can use, there's a couple different ways to do it. You can use OPC UA or OPC DA, we support both, to move data from your source, which would be either a OPC UA or an OPC DA server, move it across the diode to our OPC DA or OPC UA server, and then use a PI interface, right? And suck it up from either UA or DA. That's probably the easiest way to do it.
What would be a recommendation for large enterprise users of AVEVA PI in the selection process of the PI replication connectors for data diodes?
Well, it would be to use our product, and what differentiates our product from the other ones out there. Number one, of course, it's not using the Linux API, and it operates in a standalone flanker using the AVEVA PI API. And there are a number of things that we do to guarantee delivery and integrity of the destination PI database. First one being that we retransmit the data like we've talked about on a periodic basis to cover any gaps. The connection between the flanker and the destination PI server, our flanker does not have to reside on the server. It can be a separate API node, which means that the communication to the PI server, if the PI server is in the cloud, for example, is over a TCP connection, so it's guaranteed delivery. If for some reason there is a disconnect in data, we also perform a historical backfill, which means that the blue side is retransmitting historical data on a periodic basis to cover any gaps in the data that may have occurred during a disconnect, either because of a network failure or a hardware failure. You can easily recover that.
Great. I have one last important question for you. How can people book an appointment at AVEVA PI World in Milan to come and have a detailed discussion with you?
To send your check, should I give them my bank account? They could send me a check. That would work, wouldn't it?
Yeah. So which language do you use in your codes?
I use
English and Spanish.
Sometimes I use Spanish, but actually I do my comments in Spanish.
Yeah, I actually meant the coding language. Which one do you?
Oh, I use C#.
C#, not C++?
C++ for the low-level code, because I wrote the low-level code for the diode as well as the PI interface. So the low-level code for the diode is all done in C++ for speed.
Yes, speed I agree full-heartedly with. But then some people tell me that C++ has a memory problem, which is unsafe in some cases, so they prefer Rust. What is your opinion on that?
I stick with C++ because it's ultimately the fastest. There's nothing faster. And it's a richer language than Rust, as far as I'm concerned. I can do more with it.
Perfect.
Plus, I've been programming in it for 30 years, so I about got it down.
Okay. Well, thank you so much, sir. It was a real pleasure and an honor to interview. I hope it was fun for you as well. I really enjoyed it.
All right, thank you.